Okay, so let's talk about factoring by grouping. So I had to handwrite these. Also, sorry for not being there today. I'm recovering from a really nasty cold. So I'm probably going to be coughing quite a lot through this. And I had to handwrite this because, of course, my printer decided to print this really faintly. So, if the polynomial has 4 terms, you should try to factor by what we call grouping. So you should try to factor by what we call grouping. So we have a sample here. This is x cubed minus 2x squared minus 5x plus 10. The first step when factoring by grouping is to group terms 1 and 2 together. And terms 3 and 4 together. So let's rewrite this. We've got, I'm going to do this in a different color real quick. This group here, x cubed minus 2x squared. And then this other group, negative 5x plus 10. Notice how I do group the sign in with this group, because now we have a leading coefficient that's negative, so our GCF is going to be negative. That's just a little spoiler as to what's to come. So it does matter that you include the sign in that second group. Okay, step 2 is to find a GCF from both groups. Find a GCF from both groups. And undistribute. So in this case, the GCF from the first group, x cubed minus 2x squared, that's going to be x squared. So the GCF from this is going to be x squared. So the GCF is x squared. And the GCF from our second group is going to be, because the leading coefficient is negative, the GCF is going to be negative 5. GCF is going to be negative 5. So I'm going to pull out an x squared from the first group. And we're going to get x minus 2. Alright? And then our second GCF is negative 5. When I undistribute that, I'm going to get x minus 2. And note that if you did this correctly, you can see that here are my GCFs. Here are my GCFs from both of the groups. And you should get the same thing in both sets of parentheses. So step number 3 is we're going to write this as 2 factors just like this. And the first factor has the GCFs of both groups. The second factor has the undistributed parentheses. Or the undistributed remainder. I'm going to call it the undistributed parentheses. These should be the same. So, our first factor has the GCFs. This is going to be x squared minus 5, because we've got x squared minus 5. So that's our first factor. Our first factor has the GCFs from both groups. And our second factor, which I'm going to highlight in green, has the undistributed parentheses from both groups. The reason why we can write it like this is because x minus 2 is now a common factor from both of these groups. And this is my final answer. Okay, so now I am going to move to the sample problems. Remember that you can pause this video at any time, rewind, fast forward, whatever. And you can rewatch this video at any time as well. It is always available in Canvas. So let's move down to the guided samples below. So for the first one, we are going to group both of these. And feel free to pause and take a moment to see if you can find the GCFs from both groups before I go over it. Alright, so the GCF from this one, 6n cubed plus 3n squared, is going to be 3n squared. And the GCF from this one, 8n plus 4, is going to be 4. So when we undistribute the GCF from both, we're going to get 3n squared times 2n plus 1 plus 4 times 2n plus 1, where 3n squared and 4 are my GCFs, and 2n plus 1 is now my undistributed parentheses. So my two factors are going to be 3n squared plus 4 and 2n plus 1. Oof, sorry about that. Okay, for this next one, also, real quick, make sure before you start factoring in any way, shape, or form, this is the same for any kind of factoring that we do, make sure that there is no greatest common factor among all of the terms of the polynomial. Otherwise, you have to deal with that first before you do any other method. So in this case, let's take a look. We've got 9, 6, 15, and 10. Well, because of this 10, and 3 can't go into 10, we can't just factor out a 3. We also can't factor in an x because this doesn't have an x on it. So there is no greatest common factor among all 4 terms. So now we're just going to do regular grouping. We've done the check for a GCF across the whole thing. Now we have to do grouping. Alright, the GCF for the first one, take a moment to figure that out, should be 3x squared. And the second one, because it's negative, the leading coefficient is negative, should be negative 5. So we've got 3x squared minus 5 times something. Alright. Now we're going to undistribute a 3x squared from our first group. 9x cubed divided by 3x squared is 3x. 6x squared divided by 3x squared is 2. Negative 15x divided by negative 5 is 3x. And negative 10 divided by negative 5 is positive 2. So you can see that this works out very nicely. We've got 3x squared as our first GCF, negative 5 is our second GCF, and our undistributed parentheses are both 3x plus 2. Alright, so we know that this does factor by grouping now. And we get 3x squared minus 5 and 3x plus 2. In the event that these undistributed parentheses are not the same, you either have not done it correctly or this just doesn't factor. Which is possible, but we're not going to see that yet. We're not going to see that yet. Okay. Now let's move on to the next few. Okay, so we have 6, 8, 12, and 16. We're doing a GCF check here for all 4 of these terms. Note that there isn't a common variable among all 4 of these terms, so we couldn't pull that out if we wanted to, but all of these terms are even. So we can actually pull out a 2 from this whole thing. So let's pull out a 2 from this whole thing, and I'm going to do this in a different color. I'm going to do this in purple. Alright? So we've got a 2 outside of this whole thing. 3x cubed plus 4x squared plus 6x plus 8. And now we can do grouping with what's left here. Okay, so the GCF from our first group is going to be x squared, and the GCF from our second group is going to be 2. So we've got x squared times 3x plus 4 plus 2 times 3x plus 4. Sorry about that. And so now we can write our final answer as our big GCF of 2, the GCF across all 4 terms is 2, times the first factor, which is the GCFs of both of our groups, times the second factor, which is the undistributed parentheses from both of our groups. So we have our overall GCF plus the GCFs from both, or times the GCFs of both of our groups, and times the undistributed parentheses. Alright, for this last one, we have a GCF of, I'm going to let everyone take a moment to figure out what the overall GCF of this is. There is an overall GCF. So pause until you figure it out. Okay, it is 2x, or it is negative 2x. There we go. It is negative 2x because the coefficient, the leading coefficient, is negative. So it is negative 2x. And so we've got positive 12xy plus 18x minus 20xy divided by negative 2x is negative 10y. 30x divided by negative 2x is minus 15. And now we can do grouping. Yeah, that pink is really not showing up well. Let me see if I can, yeah, that might help a little bit. So, the GCF from our first group, take a moment to figure it out. It is 6x, and the GCF from our second group is negative 5. So we've got our negative 2x on the outside, our overall GCF. Then we've got 6x times 12xy divided by 6x. We're undistributing the 6x from the first group here. 12xy divided by 6x is going to be 2y. 18x divided by 6x is going to be positive 3. Then minus 5 is our second GCF. Negative 10y divided by negative 5 is positive 2y. And negative 15 divided by negative 5 is positive 3. So we have our undistributed parentheses, our two GCFs. Oof, sorry. And our final answer is negative 2x times 6x minus 5 times 2y plus 3. Because our overall GCF is negative 2x. Our GCFs from both of our groups, 6x minus 5 and our undistributed parentheses 2y plus 3. Alright, work on the sample problems by yourselves or with your groups. Work on the sample problems on your back. Work on the sample problems on the back. And again, in the event that the undistributed parentheses are not the same, it's either you did something wrong or it does not factor at all. In the event that that happens, your answer will be, this polynomial does not factor.